So hi guys, so today we would be starting with another topic, the ML topic, that is reinforcement learning. So previously what we talked about three learnings, that was supervised learning, unsupervised learning and semi-supervised learning. So just for a recap, I would just again pronunciate the definition of all the three. So supervised learning was like this: the training data you feed to the algorithm, it includes the desired solution called labels. Now the second one was unsupervised learning. The training data is unlabeled, the system tries to learn without teacher. And now semi-supervised learning. Some algorithms can deal with partially labeled training data, usually a lot of labeled data and a bit of labeled data. So coming to the next thing, that is reinforcement learning. So this is a very different thing as compared to the other three learnings we studied. So reinforcement learning is a subfield of machine learning where the machine learns, lives in the environment and is capable of perceiving the state of that environment as a vector of features. So not a problem if you don't got anything from the definition. I would just explain you an example, that the learning system is called an agent. So in this example, you can see this robot is a agent in this context, and it can observe the environment and select perform actions and get rewards in return. So this is the environment. This whole thing is the environment. Now after this, it must then learn by itself what is the best strategy called a policy to get the most reward over time. Now suppose what the agent would do in the environment, it would observe that okay, what things are present here and all, and then it would select action using a policy. Now the action has taken place, the robot goes to the left, that is where fire is there, and it gets rewards or penalty, and here it got minus 50 points. Hence the algorithm would learn from here that okay, I won't go to the left next time because there is fire and I would get penalty for that, and it would learn from here, update the policy that next time avoid it. It would iterate until an optimal solution policy is found. And so coming to one of the very famous example of this is the DeepMind's AlphaGo program. So if you don't know about DeepMind, it was, I guess, brought up by Google to a few years back, and basically it does researches on machine learning, deep learning, artificial intelligence. So AlphaGo program is also a good example of reinforcement learning. It made the headlines in May 2017 when it when it defeated the world champions KJ at the game of Go. If you don't know about Go, it's basically a board game that was invented in China yeah, many years back, and yeah, you can see it's something like this. And so what happened, they trained the AlphaGo model on that board game many times, millions and millions of times. They trained it. It learned its winning policy by analyzing millions of games and then playing many games against itself. So what happened, suppose I would just take a image here, and this, suppose this is the game. This is the game where all the things are put up, the how the game is played, I exactly don't know about it, it's a board game. So what it does, every time it got defeated from this path, it would learn that okay, if these are specifically if the player who is playing against me has this position, I won't go here, I would go here, and it would get some penalty from here. So from there it would get a reward function if when it performs good. So from penalty and reward function, it gets to know okay, I would play like this. It's similar to like that when in childhood, when a student is writing something, and suppose it wrote something wrong and got minus 2 marks for that in his or examination, it would remember, he would remember for the next time that okay, next time I won't do this mistake, specifically not this one. Maybe he or she does another mistake, but from that also it will he or she will learn, but it will not repeat that particular mistake. Now coming to the next part, that is very famous example that I already talked about, that is AWS Deep Racer League. It is similar to a reinforcement learning competition. What happens in this competition is you basically train a model, and you can imagine a path like this. This is a path of the model, and suppose if the model goes off track, it would get some penalty that okay, you have gone off track, next time you need to avoid that. After the models get penalty, it would next time not go that side, it would go maybe in this side. now it would get again a penalty that you don't have to go this side also, because there is this is off track. Now the model would next time go in front, and it would get a reward function for that, that you have performed good, you are getting some reward function, some reward for that. So you are, what you are doing, you are basically making a model learn by the winning policy. You are analyzing millions and billions of possibilities of right and wrong, and from that you are learning of how to make your model the best model in this whole competition or whole program of reinforcement learning. So I would suggest you to go and explore these racing tips and all, how things in reinforcement learning work in basically this competition. It's active even right now. How AlphaGo is working. It's going to be really nice for you to see how models are working, how some real world life examples are working through reinforcement learning. Basically, many robots implement reinforcement learning algorithm to learn how to walk. Means suppose a robot is working this way and this way, just similar to how I told you about AWS deep racer and AlphaGo. You are making the model learn from the by analyzing millions of game, and by seeing the winning policy and losing policy. So this was it for the video. I hope you got the idea what basically reinforcement learning is. It's totally different from all the three learnings we have learned before. So you can go and check out the documentations and read more about it. Thank you and have a nice day.